Good morning, Algebra 1. We today will be doing classwork 152, section 710 with homework 153, page 338, orals number 1 through 24 all. Here is a problem of the day. We have right here. Go ahead and pause the video, write down the problems, and express each of these as a power of 10. So if you're like, power of 10, what is she talking about? That means, for example, number 100, I want it written as 10 to some power because 100 can be expressed as 10 squared. Go ahead and rewrite the next 4 as a power of 10. All right, hopefully you paused the video. Let's go back and go through the answers. 10 to the first power is the same as 10. 10 to the 0 power is 1. Anything to the 0 power, remember, is 1. All right, we get down here to D and E. This is just like we were doing with negative exponents. So this is the same as 1 over 10 to the 1 over 10, just like up here, or 10 to the negative 1 power. And down here we have 1 over 10 squared, which is the same as saying 10 to the negative 2. So what we're going to get into today, and I'll give you the objective in a minute, is scientific notation. We're going to be using 10 to some power multiplied by another number to express a number. So we have, our objective today is to use scientific notation to express very large and very small numbers. So an example of a very large number would be like a light year. A light year is approximately 6 trillion miles. And so if I was going to express something in light years, the speed of light, I would express something, 6 trillion is a really large number. We can also, so the speed of light, we could use scientific notation to also express the speed of light, which is 186,000 miles per second. You're going to go ahead and open up your book to page 336. Go ahead and pause the video right now and read the paragraph at the top and look at the example in the box there. All right, so you've looked at the example in the box, and they have, what is that, 118 million, billion. We can express it as 1.18 times 10 to the 11 power. And what we're going to do today is move the decimal. This is really not that difficult, not really confusing either, and you're going to catch on to this. So I have some examples on the board. Let's go ahead and look at example 1. So example 1, we have hundreds, thousands, millions, billions, trillions, 64 billion, 830 billion, trillion, billion. And what we want to avoid is having to write this number as this huge number here. So what we're going to do, this is a whole number, this is not a decimal. I'm going to put my decimal at the end, and I'm going to move my decimal until I get to right here. And I'll tell you about this. This is going to be called a significant digit. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I've moved my decimal place 13 places to the left. So how I'm going to rewrite this is 6.483. And the reason we're writing it in scientific notation is to get rid of all these zeros times 10 to the 13. So what this is saying is 6.483 times 1 with 13 zeros after it. So it just condenses the number down to basically a manageable number. Still representing this. All right, let's talk about a big long decimal, changing it to scientific notation. So if I had a whole number, I moved my decimal to the left. I now have a decimal. I'm going to move my decimal to the right. I want to get all the way down here to in between 8 and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what I have here is 8.9 times 10 to the negative 10 power. This is the same as saying 8.9 divided by 10 to the 10th power. Makes sense from 2 days and then the day before. Except I want to bring this up here to the numerator, so I have to multiply and change the sign of my exponent on my 10. All right, so we've gone that way and this way. My decimal moves to the right. Let's talk about another term that is related to scientific notation, and that's called a significant digit. A significant digit are the numbers that need to be written here. Notice I only write these digits. I don't include all the zeros because that's the purpose of scientific notation. And we would call these 4 digits significant because they are not 0. I can't represent them as 10 to some power. So these are called significant digits. Now we're going to see, I'll do another example where we have 0, and if I had 0 in between here, it would also qualify as a significant digit. Let's talk about one other thing, how to properly write scientific notation. You are only going to have a value of one number in this ones place value. Everything else will be a decimal. So just like we've got written here, I have one number in this ones place value. This is improper. If I had 2 numbers here, improper scientific notation. I want that decimal only to have one number to the left. So while I'm here, what we're going to do, we're going in reverse. Example 1 turned this big number into scientific notation. Example 3, we're going to turn we have a positive exponent. We're going to turn this into a big, long, expanded number. So I have a positive 9, which is meaning I'm multiplying this by 1 with 9 zeros after it. So it's not a decimal. It's a big, long 1 with 9 zeros after it. So I have 6.47, and what I'm going to do is simply move my decimal 9 times to the right. So I start here, and I move it 1, 2, 3, 4, 5, 6, 7, 8, 9, and add my zeros in. So here are my commas. So I have what? Hundreds, thousands, millions, billions. 6,470,000,000 is this number right here. All right, example 4, we have 7.83 times 10 to the 7 power, negative 7 power. So this is like example 2. It's the reverse of example 2. I'm going to rewrite my 7.83 over here because I'm going to add zeros this way. So I'm going to move it, set my decimal 7 times. 1, 2, 3, 4, 5, 6, 7. Put my decimal there, 0.000000783. That's how I transform a number using scientific notation. Now in your book, go ahead and take a look at example 1 and example 2 on page 336 and 337. I'm going to get the board set up to do another example involving division. All right, I'm going to do an example similar to example 3 in your book, but it's not going to be exactly the same because you can then read that example to supplement the examples that I'm doing here on the board. Let's All right, so we have this example, example 5. 9.3 times 10 to the 12th power over 3.0 times 10 to the 4th power. All right. Immediately, your brain goes, I'm just going to convert these and zero everything out, single everything out. So I have a whole bunch of ones. No, let's go ahead and split this. We want to split this into 9.3, our significant digits. Here are our significant digits, times 10 to the 12th over 10 to the 4th. All right, let's make sure I get all that in there. So let's go ahead and divide 9.3 by 3, and I get 3.1 times, and here are my exponent rules in action. I have 10 to the 12th and 10 to the 4th, which is the same as saying 10 to the 12 minus 4 power. So I have 3.1 times 10 to the 8th. Does that make sense? Did you follow? This is my final answer written in scientific notation. All right, let's take a look at example 6. Let me lean this down a little bit. Didn't really work. There we go. All right, example 6, and then we will compare example 5 to example 6. Example 6 doesn't use division. Example 6, just like example 3b in your book, uses multiplication. So I have 6.2 times 10 to the 5th power times 3.5 times 10 to the 8th power. All right, do not foil this. Stop. Whenever you see, I have you well trained. Hopefully you went, am I going to have to foil that? Oh my goodness, what is she doing? No, 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 no. You only foil when there's an operation of addition and subtraction here. That's not this. This is scientific notation. This is all. There's multiplication occurring between all of these. So I'm going to multiply my significant digits. 6.2 times 3.5 multiplied by 10 to the 5th times 10 to the 8th. All right, this is the easy part right here. 10 to the 5th times 10 to the 8th. I have my exponent rule, so I add my exponents because my bases are the same, and I have 10 to the 13th. Now, 6.2 times 3.5 is 21.7. All right, you might say, I'm done. I've got scientific notation, and I'm going to say, no, you're not done. You can only have one digit to the left of your decimal. Does that make sense? Say yes. I have to move this decimal right here, but when I move that decimal, it changes my exponent to 14 because I've moved my decimal. So my final answer is 2.17, those are my significant digits, times 10 to the 14th power. Here is my answer. All right, your homework tonight are the oral exercises on page 338, number 1 through 24. Now, let me warn you, 24, you are going to have to do this, then do division. But it's absolutely nothing that you can't handle. I have faith in you. All right, again, here we are. Here is your classwork. Here is your homework. Your maintenance is coming in an email to you. I'd hop on that this weekend. Maintenance 22 is on its way to you. And I hope you have a great weekend. See you next week.